Download this code from codegive.com, link in the description below. OK, let's delve into the blind not broken technique. This approach provides a robust method for identifying and extracting data from web applications where traditional injection techniques like SQL injection might be mitigated or difficult to exploit directly. It relies on observing the application's behavior to make deductions, much like how you would use your other senses to navigate a room with your eyes closed. What is blind not broken? Blind refers to the fact that you don't get direct error messages or data output back from your injection attempts. You can send input, but you don't see the results of that input in a straightforward way. Not broken signifies that even without immediate feedback, you can still exploit vulnerabilities by understanding how the application reacts to different inputs. These reactions can be timing differences. The application might take significantly longer to process a malicious payload than a normal one. Different response content. The presence or absence of specific content in the response, example a success message, a 404 error, might be influenced by your payload. State changes. The state of the application, example user logged in, item added to cart, might change based on your injected input. Key concepts. 1. Character by character extraction. The core principle is to extract data one character at a time. You send a series of requests, each designed to test a single character of the secret you're trying to uncover, example a password, database version. 2. Conditional logic. You use conditional statements, often in SQL, but adaptable to other injection points, to make the application's behavior dependent on the truth of your character guess. 3. Binary search, optimization. While you can iterate through every possible character, AZ, 0 to 9, symbols, a binary search greatly reduces the number of requests needed. 4. Injection points. This technique works best where you can influence the application's backend processing, even without direct output. Common injection points include SQL injection. The most common use case. LDAP injection. Similar principles apply to LDAP queries. OS command injection. Where you can execute commands on the server. XML external entity, XXE, injection. Inducing the server to load external resources. Server-side template injection, SSTI injecting code into template engines. Example, blind SQL injection, MySQL. Let's say you found a vulnerable URL. You suspect that the ID parameter is vulnerable to SQL injection, but error messages are suppressed. Here's how you might proceed. 1. Identify the vulnerability, confirmation. First, try to confirm the vulnerability. You might try injecting a simple conditional statement that is expected to be true, such as a sleep command. If the page takes 5 seconds longer to load than usual, it's a strong indication that your SQL injection is being executed. 2. Database version extraction, character by character. Let's extract the MySQL database version. We'll use the substring function to isolate a character at a specific position, and compare it using ASCII. We'll test if a specific character is greater than the characters we are looking for. Here's how it works. Version returns the database version string, example 5.7.30. Substring version n1 extracts the character at position n, starting from 1, from the version string. ASCII converts a character to its ASCII code. Explanation of the code asterisk is _vulnerable, this function injects sleep, 5, and checks if the response time increases significantly, confirming SQL injection. Asterisk extract underscore data, data underscore type, asterisk this is the core of the blind extraction process. Asterisk it iterates through each character position in the version, string. Asterisk it performs a binary search, using low, high, and mid, to find the ASCII value of the character at that position. Asterisk the SQL payload tests if the ASCII value of the character at position I is greater than mid. Asterisk if the page sleeps, takes longer, it means the condition is true, so you increase low. Otherwise, you decrease high. Asterisk the loop continues until low and high converge on the ASCII value of the character. Asterisk main execution asterisk. Asterisk the if underscore underscore name underscore underscore equals equals underscore underscore main underscore underscore colon block runs the vulnerability check and the extraction process if the vulnerability is confirmed. How the binary search works asterisk. Imagine you're trying to guess a number between 1 and 100, and you're only told if your guess is too high or too low. 1. Start with the middle, 50. If it's too high, you know the number is between 1 and 49. 2. Guess the middle of the new range, 25. If it's too low, you know the number is between 26 and 49. 3. Keep having the range until you find the number. This binary search strategy dramatically reduces the number of guesses required compared to simply trying every number from 1 to 100. Important considerations. Asterisk rate limiting asterisk web applications often have rate limiting mechanisms to prevent abuse. You might need to introduce delays in your script, using time.sleep, to avoid getting blocked. You might also consider rotating proxy servers. Asterisk false positives asterisk network latency or server load can sometimes cause false positives. Run your script multiple times and verify the results. Asterisk WAFs, web application firewalls. WAFs often detect common SQL injection patterns. You might need to use techniques to bypass WAFs, such as asterisk character encoding asterisk using URL encoding or hexadecimal encoding for characters. Asterisk comment insertion asterisk adding comments, slash asterisk comment asterisk slash, to break up patterns. Asterisk case mixing asterisk changing the case of keywords, example select instead of select. Asterisk error handling asterisk add error handling to your script to gracefully handle unexpected responses or network issues. Asterisk database specific syntax asterisk the specific SQL functions and syntax will vary depending on the database system, MySQL, PostgreSQL, SQL Server, etc. Adjust your queries accordingly. Asterisk other vulnerabilities asterisk sometimes, by identifying that there is a blind SQL injection, it's possible to find another vulnerability that is easier to exploit. Generalizing the technique. The principles of blind not broken can be applied beyond SQL injection. Asterisk LDAP injection asterisk you can use LDAP filters to create conditional logic and extract data based on timing or the presence/absence of certain attributes in the response. Asterisk OS command injection asterisk you can use commands like ping with a conditional IP address, example ping C1192.168.1.1, if $IDU, GT0, then sleep 5, phi, to create timing-based exploits. Asterisk XML external entity, XXE, injection asterisk you can try to load external resources based on conditional logic. For example, you could try to load a file only if a certain condition is true. Asterisk server-side template injection, SSTI this is more complicated, but you can sometimes use template language constructs to create conditional execution and observe timing differences or changes in the response. Ethical considerations asterisk. Always have explicit permission before testing web applications for vulnerabilities. Unapproved testing is illegal and unethical. Use this knowledge responsibly to protect systems and not to cause harm. In summary, the blind not broken technique is a powerful way to exploit vulnerabilities in web applications, even when direct feedback is limited. By carefully observing the application's behavior and using conditional logic, you can extract sensitive data and potentially gain control of the system. Remember to practice legally and ethically, and to adapt your techniques based on the specific vulnerability and the application's environment. Understanding the underlying database or system is key to crafting effective payloads.